Hello everyone, welcome to the second video of the first module. I'm going to talk about the Malthusian economy and I'm going to explain to you what the Malthusian model is. Let me erase here my notes a little bit. Yes, okay, so let's just start from two facts. We saw in the last video that income per capita revolved around a subsistence level over time during the Malthusian epoch. So there was not much variation, long-term variation. There was short-term variation in income per capita, but not long-term variation. And there is another fact that we know from historical evidence for most societies that we have documents for, and that population growth rates were more or less stable. So before the 1800s, before the Industrial Revolution, the number of children per woman that survived to adulthood was always just a little above 2. We know that world population grew from 0.1 million in the 130,000 BC to 770 million by 1800. But the number of surviving kids per woman was on average around 2.005. So we have to explain, on top of explaining that income per capita was revolving around subsistence levels, we also have to explain that there is some sort of force that kept population growth rates limited over the long run. How can we explain that? So economists, they came up with what is called the Malthusian model, and I'm going to explain to you intuitively how the Malthusian model works. So the first component that you have to have in mind is that as income rises, and I'm calling income here y, small y, as income rises, birth rates increase, so B, and death rates decrease. So overall population increases. So what is the mechanism here? So you have more income, think about food. So you have more food, so you can sustain more people, more children survive, and less adults die out of starvation. So population will grow. Okay, if there is a shock, a positive shock on income per capita. And the second component of these models is that resources are fixed. So I'm calling resources big R, and they are fixed. So the way we think about this is that imagine that the society we're looking at is an agricultural society, and they produce food out of a fixed piece of land. Over time, they only have that piece of land. They don't have much more, and it's really hard for them to devise new techniques to have a higher agricultural productivity out of that land. So the amount of land that they have is fixed to produce food. So this is a resource. And the third component of a Malthusian model is that there are diminishing returns to labor. So labor here I'm calling L. So what does that mean? It means that the productivity of every additional person that is added to the workforce, so that works on the land, is smaller than the productivity of the person that came before her or him. So you still have positive productivity. So if you send that person to the field, he or she will still be able to get some food out of the land, but his or her productivity will be smaller than the productivity of the person that came before. So these are the three components of the Malthusian model. And the basic message of the Malthusian model is that in the long run, every additional positive shock on income will be absorbed by population growth. How does it work? Income per capita increase, then there is a population increase. Then because resources are fixed and there is diminishing returns to labor, society cannot sustain that extra population. So income per capita will go down. There won't be enough food to feed everyone, and then population will go down. This is a short-term increase, and this is the process in the long run. So the Malthusian model basically tells us that in the long run, population growth and income per capita will stay stable because of this three components I mentioned. So resources are fixed, diminishing marginal returns to labor, and the fact that an increased income will increase birth rates and decrease death rates. Let's now go a little bit more formal and define things in mathematical terms. So let's consider a society with a given birth rate and a death rate, B and D. And these are determined by culture and living standards. So there are some societies in which, because of their culture, women have more babies, and some society where they have less. And we simply define birth rates as the number of births per year per person and death rates as the deaths per year per person. A stationary population is a population of constant size in which birth rates equal death rates. So if we have a stationary population, it means that I'll call it P star. It means that the birth rate is equal to the death rate. So the number of people that are entering that society is exactly equal to the number of people that are dying, that are exiting society. And let's define now Y star as a subsistence income. So this is the income at which birth rates equal death rate. So you have just enough to sustain that population. And let's call N star the stationary level of population. So where population growth is zero at this level. Let's now suppose that there is a shock and there is an increase in the level of income equals to Y0. So Y0 here is bigger than Y star. Again, Y star is the subsistence income. So it's the income at which population is stable. Then, as we saw earlier, the birth rate will exceed the death rate and population will grow. Population growth puts pressure on resources and then income per capita will fall. So there won't be enough food to sustain everyone. And then income will also fall and the death rate will rise and birth rate falls. And we're going to go back to the equilibrium population, so the stationary population. So here I took this picture from A Farewell to Alms by Gregory Clark. So this is the graph that shows the dynamics of the Malthusian model. So Y star is the stationary, the subsistence income. There is a shock. Say someone invented a new type of seed, which is slightly more productive and generates more food. Then there is an increase in birth rates, decrease in death rates, but that puts pressure in the system, and then in the long run, the system tends to go back to the subsistence income and stationary population levels. So basically, uh, and then one-off improvement in technology, for example, the introduction of a new crop, which increases productivity enables a period of population growth and temporary high incomes. So we see that over the course of history. So in places, uh, in several places like in the Middle East, in South America, there were times in which income per capita was higher than the subsistence level of income. And this happened because a technological improvement happened. However, in the long run, and this is the key difference, which is important here, is the difference between a short run shock and a long run dynamics. So the long run dynamics of the Malthusian model is that population growth is stable over time and income per capita is stable around the subsistence level. But it doesn't mean that there are now no variations, short-term variations over these two variables. So the rule, the Malthusian trap, if you want to say that, is that in the long run, per capita income will always return to the equilibrium levels, the subsistence income level. And countries are different, so because they have different values of population at equilibrium. So countries have different values of stationary population. So what I'm calling N star. So everyone in every society on average is living at the subsistence level in the long run, Y star. However, societies have different numbers for stationary population. So for example, ancient Rome have a larger stationary population than some tribes in South America. And the difference is marked by different population densities. So ancient Rome is more densely populated than South America. However, the key is that on average, in those societies, people are living at the subsistence level. Again, of course, there are elites, and of course, there are some people in the societies that have an income per capita that is higher than subsistence level, but on average, this is where everybody is at. Is at. Okay. And what are the typical shocks that change income per capita, that change birth rates, that change death rates? So these are the famous ones that we see in history books. So plague, war, revolution, state collapse. And the model suggests that some of these very tragic shocks, like plague or war, they have a silver lining. They increase average income in the short run. And then everyone is a little bit wealthier in the short run. And then over time, things will go back to the stationary population level and to the income subsistence income per capita. A very cool example. Well, there are several examples in history. So if you want to have a look, there is this Ashraf and Galler 2011 book that it shows that countries that underwent the agricultural transition earlier, so people were nomads and then they settled in pieces of land and then they started to work the land. They show that in societies, countries where this happened before had a higher population density in the 1500s, but they did not have higher per capita incomes. So the equilibrium stationary population was higher, more people per square meter, but they are, again, the average person in the societies in these countries was living around the subsistence level. And there is a very cool case, which is in Galler's book, The Journey of Humanity, which is the case of Black Death in Europe. So we know that Black Death in Europe caused an increase in death rates. Almost one third of Europe died because of the death rate of the Black Death. Then there were fewer workers to work the land, so there was an increase in equilibrium wages, and this resulted in an increase in standard of living of workers. So you had more food and more material things for everyone because less people were living in Europe. And then because of that, because of this prosperity, there was an increase in birth rates and a decrease in death rates, which resulted, as we saw, in an increase in population, which followed by a reduction in standards of living, putting the system back to the equilibrium rates. And here, this is a graph from Galler's book, which tells us exactly that. And it's actually a very interesting graph because it shows the long run pattern. So here, on the left axis, we have real farm wages, and we see that right at the peak of the Black Death, there was an increase in real farm wages, which peaked 150 years after the peak of Black Death. And then it went down over time. So there was an increase in the material conditions of these people in Europe. And population went down because of Black Death as income was going up. But over time, population went back to the equilibrium level and income per capita went back to a subsistence level. And this happened in almost 300 years. So this is what I mean by short term versus long term. So the long term pattern of the societies in Europe is a pattern that revolves around stationary population and subsistence income. But there are short term shocks that deviate the societies from these equilibrium values.